Right. So we have discussed number 3 is for understanding. We have understood the script to some extent. We were able to submit the script using the qsub command. We were able to track the job status using the qstat command, and we were able to see the output and error files as a result of running the code. Okay. So now we'll go into a bit more detail. So this slide number 10 has details of all the commands we ran, starting from the virtual environment, setting up the environment, to using the qsub command. The script has been uploaded on the codes folder in the Google Drive. Later I'll push it to the class repository as well. So let's have a slightly more detailed discussion on the PBS script. There's a lot more than what we had in the script. So let's try to understand that. What we'll do is we will check the manual for the qsub command using the man command. So we are back on the cluster. So let's do a manual for qsub. So this is the manual for qsub. So let's, there's a lot here. I'll not read everything. I'll just highlight the key important ideas. So first is about environment variables. So there are some environment variables which are available by default to you on the head node or in any machine. So when you send the command to the compute node, the environment variables in the compute node, the standard ones may be different. So to differentiate, what happens is environment variables starting with pbs_o will be created. So on the compute node, these environment variables, for example, home is the home environment variable which is available on your head node. Okay. And when the job gets sent to compute node, on the compute node, that home that was available to you on the head node, which you were seeing when you were sending the when submitting the job, is available as pbs_o_home. Okay. So some of these environment variables get ported to the compute node by default, and there is a command that is used to send all of them. For that we had this -V to send all the environment variables. Okay. So you can use some environment variable. In fact, they are very useful. So I have an assignment exercise for today where you have to use these environment variables to do something interesting and create some automation in the system. So some of them are listed here. There's a host, server, queue, which queue you are running on, working directory, which is the absolute path of the directory which was used for sending the qsub command. So you were sitting in some directory to send the command. There's an array ID which we'll talk later in the course for sending an array of jobs if you're doing some parametric study. A job ID, something got printed on the screen, right? That number. So you can also refer to that by this environment variable. Job name, so that is the name you had set. So you can also extract it back using the job name ID. So these can be used in your PBS script to do something with them. PBS node file, so this was the file name that contains the list of compute nodes that the job was sent to, and there is a PBS queue which contains the queue name that you were sending the job to. Okay. So what we can do is we can use some sort of conditionals with the use of these environment variables to do some automation. An example would be, for example, I've given you an assignment on this. So let's say there are a couple of nodes on the cluster which have Python 3 installed, and there are other couple of nodes which have Python 2 installed. So you have different versions of code, one written for Python 2, one for Python 3. So depending on where your job went to, you can have an if condition in a bash PBS script. You can check where your job was sent using hostname command, hostname environment variable, and then you can use that to decide what you want to do. So that's just one thing. You can also have something else where depending on what queue you are sending the job to, you will do something different. So if you're sending the job to a day queue, you want to run the code for this amount of time in terms of time steps. If you are running it on the week queue, you have to do it for this case. So all you do is on the top you change the queue name, but in the code, in the bash script, it will automatically take care of what happens next. Okay, so this gives you some sort of automation opportunities to utilize when you are using the scripts. Let's explore this a bit further. So I'll only stop at things which are more useful to start with. So there's an -H for putting a hold on the job at the submission time. So you may want to send the job, but you still do not want the job to be run as of now. Could be for any reason. For example, you have dependencies involved. So you have the result of job A is going to be used in job B. So what you will do is you will put a hold on job B, and then you send job A. As soon as job A runs, then you will release the hold on job B. Although there are better ways to do it by specifying dependencies in scripts. So with job names you can do that, because you have different names for different jobs. So you can put you can have dependencies in the PBS script, so that one will start only when the next will complete, or one will start only when the the job it is dependent on will complete. Okay, so holds can be placed depending on what you want. This -I is very interesting. It allows you to work interactively, in the sense that it takes you to the compute node and then you can type things. It's like IPython. Remember, we were using IPython for doing things while practicing, and once we are happy with things, then we can use the standard Python script. So we can do the same thing. Now doing IPython on a local machine is different from doing IPython on a compute node. So this way, if you send the job interactively, as soon as you get the time, it will automatically take you to the compute node, and then you will have a blinking cursor. Now you can do anything you want on the compute node, but legally, not doing an SSH directly, but through the scheduler. So if you want to test for some environment, what sort of environment variables are available on the compute node, for example, when the job is sent there, you can try these things out with an interactive job. So we will actually do that to solve an exercise today. Okay. -J is for joining. So earlier what we did was we had separate files for output and error. You can use a -J to combine them, and everything, error and output, both will come into just one file as you see things on the screen. It's in case you want to use that. -L is very important, as we showed you that it's a resource list. The memory you want, number of nodes and cores you want, runtime, wall time you want, everything can be specified through -L. Mail options, actually mail is not enabled on a cluster, but sometimes in some clusters it's available. So then you can set up mail options, you can set the mail ID and so on. So it will automatically send some details as to when the job was sent, when was it, when it started running, when it terminated. All these things will be sent to you as email, which is very useful. But this is not available on the cluster we have here, but you can do some of your own hacks to generate some script. I have a script available with me, which I use which I run on my local machine, which will send me an email. I'll show that script to you as soon as the job starts working, and when it gets completed, it will send me an email that job was completed. So that's very useful, because you don't have to keep logging to the cluster and say that no, but I'll not share the script with you, I'll let you write it yourself. That's an assignment as well. And then I'll give it to you later if you are not able to write the assignment. The point is that these things can be done easily. It's not that difficult. It saves a lot of time and anxiety for those who keep logging into the cluster every 5 minutes and seeing qstat as to what is the status of my job. Okay, that takes your mind away from something useful that you could have been doing, other than just checking the status of jobs. -N is to check. -N is actually again very useful in certain cases. If you want to send your job to a particular compute node, let's say N41, so you can use a -N and specify the address of the compute node that you want the job to be sent. Now that's scheduler's choice to figure, like scheduler's job now to figure out how to prioritize that. If it will only send it to N41 when it's available later, then you have to wait. Or it may figure out that yes, you have some particular reason for doing that. So depending on how the scheduler has been set up, your job will only be sent to N41 whenever it's available. So that way, sometimes people have their own, people have some software installed on request on certain nodes, So they can force their jobs to be sent on those ones. So this minus n allows you to send the job on a particular compute node. Minus capital N is for name of the job, as we saw. You can give it a nice name. So a priority is something that I don't know if it works on the cluster as of now, but usually it's not enabled in our cluster. It was not enabled earlier. So in some cases you can set the priority yourself. It's usually by default it's 0. So if you give it a positive priority, it may happen that it may get submitted quickly, but I think it doesn't work that way as for us. But it usually works like this for those who are on a payment basis. If you put a higher priority, then you may have to pay more. So that ways you can set a priority on this job. It's a low priority, you can put a negative up to 1024. That ways it will get submitted later, but it may not be charged, or it may be charged less. For us, since there is no charge, I think it doesn't work. Minus q is again necessary for sending the q, giving the queue name as to which queue you want to send it to. Minus t is for array request. So let's say I want to do a parametric study of 100 different parameters from 1 to 100. People usually use this for designing something. So I'm designing some let's say for fluid mechanics, I'm designing something for an angle of a nozzle. So that nozzle will have different angles going from let's say 3 degrees all the way to 60 degrees. So I have and 1 degree each. So I have a total of 60 minus 3, which is 57 plus 58 options to try. So rather than submitting 58 jobs manually, which is again a lot of waste of time, what you can do is you can set an array request. So that ways you will, this array request will automatically generate those 58 jobs as an array of jobs, and then it will get sent and get executed as 58 different jobs would. So that helps you, because then with the array you can actually you can say qsub followed by the script name followed by a minus t option, and then the range of numbers you want. So from 3 to 60. So it will go from 3 to 60 in steps of 1, and this %5 basically means that how many of these jobs you want to run at a time. So it may happen that if you run more than 5, it may, some dependency issues may occur, but you can set this also, but usually we don't set that, we let the scheduler take care of that. So this allows you to run array of jobs. Okay, it's very useful again, and we'll do it when we discuss some scaling analysis later. So minus capital V is for sending all the environment variables to the compute node. That ways you have to decide which one you would want to send. And the last one we'll want to talk about is, let's do a page down quickly, is minus capital X. That's for X11 forwarding. So in case you want to use display, let's say I want to use Jupyter Notebook on a compute node. So then I can use minus capital X, so that will export the graphics, but that will be excruciatingly slow. You are sending the information from compute node, is going to the switch, is going to the head node, that's going to your your machine. It becomes so slow that you will end up not using it. But in case you want to test something or something else, then you can or some software will only work through GUI, then you can actually use that through minus capital X. That's if the admin has allowed that. I think on our cluster it was allowed earlier, it may still be working, but I never use it because it's too slow. Right. So that's pretty much it for qsub. You can explore these things in detail yourself if you want, but let's do a demo on interactive jobs, because that's something I use a lot to try things out. So I will want to discuss that with you. Again, what I am discussing today is just the surface. There's so much more that you can do yourself depending on what you need. You'll have to explore things. So we are just getting started here. That's pretty much it. Okay. So this is very basic. So for running interactive jobs, the first thing we have to do is we have to decide on what resources we want. So the easiest thing is you take a script. So I have a script. So let's go. So, I have this script PBS Python, which I used in the first part of the session to run a code. So, let us quickly display the contents again. Now, I actually want to use the same options that I have here for running an interactive job. That is, I want to run it on the private SEQ. I want the output in out.o, error in out.e. The name is the same resources requirement, same environment variable requirement. So, what I can do is I can do a qsub followed by the, instead of, I will put a minus capital I here and then press enter. So, what will happen now is it will submit this script only up to the point where it has the resource requirement. This code, actual code, will not be run. There is a way to send that as well, but if you just do a qsub minus capital I with the script name, it only uses the directives part, not the other part. Okay, the job has started. I have taken 2 minutes. I only have 2 minutes to try things out, which is not that much, but let us do whatever we can in 2 minutes. So, the first thing I will do is I want to see what environment variables are available. So, there is a command that we have discussed, print env. Let us do a clear. So, if I do that, all the environment variables that I have access to on the compute node, if I send the job through the scheduler, are shown to me now. So, I have an environment variable called host name, which actually sorry for that. So, it's dead again. People at the back, can you hear me? Okay. So, we have a host name option here. So, you can see that N31 is the host name here. So, it allows me to use the compute nodes address. So, what it means is that I can now use host name in my script, and that will return the ID of the compute node. Okay. So, there are many other variables available here that that I can play around with and use them as per my requirement. So, you can just sit there and do it. I can also run IPython. Well, IPython is not available because it's only available in my end of time, 2 minutes. So, I have to legally on N31. I'll just change. Working now? Let's check, switch it on and check if it's working. The red light should come up. Let's call it 30 minutes. Right, so it has started. So, let's do, so IPython is not working as expected. So, I'll have to source the virtual environment, which is available in where, so no, it's okay, leave it. So, in virtual environments, env1, 2, the one I was using earlier, which has IPython available. Nope, not in this one. Well, it was working earlier. Right. So this one. Anyways, so I found the environment where this was installed. So I can play around with IPython now. Okay. I can import NumPy. Okay. So things are working. Okay. So what I want to show you is that you can try out things yourself on IPython on the compute node and do things just to get an idea of how things will work when you send it as a script on the compute node. Okay. Any questions till now?
Sir, when you created the virtual environment, you created it in your own machine, right? But it is using the resources of the compute node.
No, I did not create. I created that on the head node. So on the file system.
Okay.
So I created that on N199.
And when you were like when you created this interactive, like using the minus I sign, so oh wait, no, I got it. Nothing. Thank you.
Okay, good. So I can also check what is well the value of the host name variable that we'll be using for some exercise, but you can try other variables as well. For example, pbs underscore o underscore node file, which does not have anything in it, strangely. So job name. So let's try a job name. So this is a job name. I can have the job ID. Okay, so all the list is here, so I can use any environment variable I want. So when I am done, I can just do an exit, and pretty much the end of the job. So if I do a qstat now, you can see that all jobs are completed. There's no job running. So that exit also kills the job, and the job is done. Just to show you -x, let's see if that works. It doesn't even like oh, display not set. Okay, so we'll have to do some settings to set the display. One more thing, let's say I want to run the job interactively or otherwise, doesn't matter, and the script in this case is using 20 minutes of resources, but I particularly want to set it to only 5 minutes. So what I have to do is, one option is to go to the script, modify it, and then change it again when I'm done. But the other thing you can do is you can actually set these options here in the terminal. So if you do a -L, which was for resources, and you say I think it's here -L, and then you specify the wall time equal to, and this time I only want, let's say, 1 minute, and I run it now. So now it's running, and I can actually show you using the print. So somewhere in the print env it has details of the wall time. So PBS wall time, which is 1 here. So I think that means it's 1 minute. Okay, so it's only running. It's only going to run for. Was it 1 second? I said. Oh, I ran for only 1 second, so it died after 1 second. right. So that's one way to figure out that. And the script is still the same. So you can the commands you enter here with qsub take precedence over the commands that are available in the script. So that way is you can play around with things by trying out different options quickly without changing the script and wasting that time. Okay, minus L, there was an option of minus L nodes, and here you can specify which node you want to send the command to. So let's say I want to send it to N31 dot. So here you have to write the complete ID path. So cluster dot IIT Mandi dot in. Okay, so this will only send it to N31. So N31 by default also it was sending to N31, but if I come out of it by exiting, and then if I try to send it to N32, now it's waiting, and it will wait until N32 is available. But in this case, it happens that N32 is not even mapped to the private SEQ, so it will never work. Okay. Now how do I? Let's check if anything is running. So all of them are completed. Now how do we figure out what is mapped to what? Well, that's not difficult. There's a command called pbsnodes, and if you run it, it gives the details of all the machines available on the cluster. So I can simply export that to a file called nodes.txt, and I can open nodes.txt now. So this whole file is open now. I want to check for N31, let's say. So I do a slash is for search N31. So details about N31 are available. So it says that it's set to SE. SE is for that priv SE, and LPR is also for low. Private queues are also part of low PR. If the private people are not using it, then low PR can use it. So it tells you its status is free. Some of them may be down for maintenance, so they are not working. Number of processes, number of cores available are 24 in this, and so on. Okay. In fact, recent jobs are also visible here in some cases. Right. Well, I can figure out which others have SE in them. N151, you can see it's also a part of SEQ. Well, it's down. So let's look for SE comma. That's much better. N134 is also a part of SE, which is free. So let's go back now, and let's try to send the job to N134. So it goes to N134. Okay, so I have decided which node I want to send the job to. Okay, so I can come out, I can change this back to, well, I can remove it, and then it will go by default to whichever node takes precedence. N31 is somewhere where it's going every time, because it may be available for a long time. Any questions? Right, so we have discussed this. The next thing we want to discuss is status. So now that you have full control over where to send the job to, how to send the job, and so on, the next thing is checking status of the job, so which is using the qstat command. So let's play around with that a bit. Let's clear the screen. We are on the head node. We'll do a qstat. So it gives me recently 5 jobs were sent. The status is all complete. What I did was I simply wrote a qstat. If I do a qstat minus a, it actually gives me a bit more detail. It has the job name incomplete. So basically A is for all. So it sends, it gives me more detail, and I can also do a minus n. So this tells me where exactly my job was sent to. So this was N31, N31, this was N134, and so on. Okay. So this has a bit more detail. I can do a qstat with the minus q flag, and this actually gives me the details of queues available. It's always good to do a qstat minus q and figure out what queues are available. So these are the queues available. You can do a minus q with a minus f. No. nothing but capital Q. So if I do a capital Q, it gives me more details about queues. So this time it tells me that for this priv SEQ, it has a max of so 0 jobs are running. Okay, maximum 7 are allowed and 0 are running. So this way I can decide where to send the jobs to. If I had sent to serial, it has only 7 running, which is strange. Usually it used to be full. So 200 are allowed in total. On week 45 are available and 30 are running. So you can see that only 15 are. In fact, infinite all are full. Infinite is for infinite time. So people have sent the jobs to infinite so that they can run very long codes. But the point is I can generate checkpoints and I can run them on week on private queues. So that ways my jobs will run quickly. So one job is waiting on infinite. So there's one person who has sent a job on infinite and that's waiting. That's not even running. They can send it to a week queue or a day queue. All they have to do is create checkpoints, and once the job is completed, 1 day or 1 week is completed, they can just use that checkpoint and run it again rather than just waiting and not doing anything. Okay. So this ways you can figure out what are the details of queues. And if you send a job, let's say let's go up and send a job N32 for example, right? Well, let me not make it interactive. I would want it to just send the job and wait. So if I do a qstat now, you can see that one job is in queue. Capital Q is for the job is in queue. And I can delete this job. I can do a qdel, and then I can copy paste the job ID. And then if I do a qstat again, so this job is gone. Okay, so you can do a qdel. In fact, you can do a qdel all, and that will delete all the jobs that were waiting or running or whatever. Okay, so that way is to delete, but don't do that. Why would you want to delete your jobs that are still running? But if you send a job, it's not working, you don't want to stay in the queue, just delete it so that it doesn't run at all. Any questions? We are out of time now and there's a bit more to discuss. So let's do that on Friday. There's no point exceeding the time here. We'll continue on the HPC cluster on Friday. But those who haven't got an account, please do check and get an account by then to practice things. Thank you.